So it's very important to train your team to always have the same time interval. The mistake there is that some people will just wait as long as they need to until they see the right result. It's generally not a good idea. This leads to false positives, where your technician that's not necessarily trained on how the equipment works and how the test is being performed, he's going to see those results on the screen. It's going to match what he was asked to do, and he's going to move on. Welcome to the Manufacturing Show. I'm your host, Chris Carolyn, consultant at Metal Analysis Group. In this podcast series, Masters of PMI, my goal is to help you be successful with positive material identification and truly master your metal testing wherever you may be in the metal supply chain. All the way from scrap metal recycling and metal production at foundries and mills to metal parts fabrication and inspection out in the field. PMI testing plays an important role in making sure everyone knows which metal they are working with in order to avoid material mix-ups that can lead to unhappy customers, expensive recalls, or even catastrophic accidents like oil spills, plant explosions, and airplane crashes. I know we don't like those things, right? So let's get to it. Today we're going to be talking about using a handheld Xrf for positive material identification. It's really the most widely used technology for PMI testing, so it makes sense to cover it. And it has become so easy to use out of the box, designed to be point and shoot, that there's less emphasis on understanding how it works and how to properly use it for getting your good results. So let's dive in. First of all, what is it? Well, XRF is an acronym for X-ray fluorescence. And that's a process where electrons are getting excited in their atoms and they're releasing energy that's characteristic of each specific element. This release of energy is then registered by an X-ray detector, and with that information, it can determine the concentrations of each element in the metal that you're testing so that it can give you the grade that you need to know. Just like the other technologies, it's matching it against the grade library based on the chemistry that you're seeing on that screen. The first true handheld XRF was developed in 1994 by Niton, now known as Thermo Niton, after Thermo purchased the Niton brand. It can be used for a variety of applications, like mining for mineral content, plastics, like children's toys or other consumer goods, lead in paint, whether on your walls or on the toys, soil for contamination and pollution, precious metals, like the ones you see at cash for gold dealers. They're using it to confirm the gold content. And of course, PMI for scrap, metal production, fabrication, and inspection. Some of the benefits of handheld XRF and why it's so widely used. It's a non-destructive technique. So the radiation that's being applied to the sample is not permanently affecting the sample. So you don't see any marks or burns like you might see in the other techniques like LIBS and OES. When it first came out, it was much faster than the old ways of doing PMI, where you had to take it to the lab and use bigger equipment with longer testing. When it first came out, you could get a test done in 10 to 30 seconds out in the field. With that, it's much more portable. That basically allowed for lab type analysis to be carried into the field in hard to reach places. It's basically point and shoot in order to get the results that you're looking for. It's also very flexible in the applications it can do. OES and LIBS, on the other hand, are more focused on metals. Some of the downsides of XRF? Well, for starters, it uses radiation to complete the test. And with that radiation, besides being unsafe if used improperly in untrained individuals, most states or countries regulate it. So you have to register the device, the government likes to keep track of it, you have to do training for individuals, you have to show that you have a safety program in place. So it has a little more headache on that side of things versus OES and LIBS. It can be fragile and expensive to repair. There are many moving parts, and when dropped, those moving parts can break easily, costing upwards of maybe $7,000 to $10,000 per repair. XRF also can't test for carbon and has trouble with other light elements as well. That's why OES has also been prevalent in PMI testing. It's one of the only ways to get carbon values in the field. When it comes to other light elements, especially those that are used in aluminum alloys, stuff like magnesium and silicon can just be seen better by the other technologies. So in often cases, if you have something besides XRF to use, you should use that. In terms of cost for handheld XRFs, they can range anywhere from $15,000 to $35,000 brand new. You do have to be careful there, as you can get what you pay for. Some of the upfront costs might be low in some cases, but if that instrument is more fragile or is not as durable as some of the other models, your first repair could easily take you over the price of one of those other models, costing sometimes $7,000 to $10,000. The X-ray tubes generally last 5 to 10 years depending on usage, but again, if they're not taken care of, they can be easily broken, which takes the cost of the analyzer very high, very quickly. In this respect, you You can kind of think of these devices like cars. So it's around $20K up front for a lot of the models available, but depending on what breaks, it can be expensive. And if you were to go to a dealership, it might be pretty expensive to fix. Those dealerships are designed to make money off service. And in the same way, the manufacturers of XRFs are trying to make money off their service as well. The difference here is that you don't have a lot of other repair options, like small repair shops around town like you do for cars. So you really have to take that into account when you're purchasing your handheld XRF analyzer. Also, like cars, there's a used market for handheld XRFs. Generally, these are going to cost between $5,000 and $15,000. But like a car, you need to take care in getting the information you need to make sure you're making a good purchase. So when you're looking at used equipment, like Handheld Xrf, you should be asking these questions. Ask for the paperwork that shows ownership and transfer ownership, making sure it's not a stolen piece of equipment, making sure it has proper records. Also ask for the service records. Knowing what kind of maintenance has been done to the analyzer can go a long way in making sure that you're making a good purchase. You also need to know the analyzer capabilities. So you should ask, what is the performance? There's a big range in cost because all the different models do different things. Some do more than others. Some do better at some things than others. So it's important to understand what you're buying. There's many different makes and models. Some common mistakes that people make when using XRF is that it's not always point and shoot. Similar to the other technologies, this is a surface technique. So if you have dirt or dust or corrosion, rust, paint coatings, you might get a value, but if you're looking to understand what's underneath that coating or underneath that corrosion, you're not going to get the right value that you want. So sample prep is very important, but not necessarily taken into account as much as it should. Most XRF equipment allows you to change the amount of time that you take to take a measurement. This creates another variable, as a 5-second shot might provide a different result than a 10-second shot. So it's very important to train your team to always have the same time interval. The mistake there is that some people will just wait as long as they need to until they see the right result. It's generally not a good idea. This leads to false positives, where your technician that's not necessarily trained on how the equipment works and how the test is being performed, he's going to see those results on the screen. It's going to match what he was asked to do, and he's going to move on. Maintenance of the analyzers, mainly dirty windows. So for example, if the window of the X-ray has been touched, you might see some extra silicon in the sample, and that can cause some misleading results as well. Also, unsafe and untrained use can lead to unnecessary exposure to radiation. The available brands, most people know Thermo Niton, Olympus, Bruker. Those three, with Thermo being the main one, own about 85% of the market. So when you're out there, you're likely to see one of those three. The other XRFs available include Hitachi, who recently purchased Oxford, and SciAps. A few things I want you to take away from this discussion today. XRF is obviously a very reliable tool that has been around for over 25 years. It's very versatile, flexible, and it'll get the job done. While it's very easy to use, lack of training and understanding of the technology and the testing can lead to misuse and false positives, leading to material mix-ups and other mistakes. And while it can be cheaper to buy up front, it could easily cost more in the long run with the fragile parts and the expensive repairs. So thanks for listening to this episode of The Manufacturing Show. Again, I'm Chris Carolyn of Metal Analysis Group. Please connect with me on LinkedIn to chat PMI or anything metals. I'm happy to answer any questions or provide recommendations. If you like this episode or have a question, join the discussion on Instagram at The Manufacturing Show. Thank you for tuning in and subscribing to The Manufacturing Show. Until next time, never stop testing your metal.